Hello everybody and welcome to the first tutorial on the Grapple component. My name is John and I am the creator of the project. The Grapple component is an add-on for Unreal Engine 4 that allows you to create interaction between different characters. These interactions take the form of what I call Grapple Sequences. These Grapple Sequences allow characters to play synchronized animations, they might affect their movement capabilities, and they also allow you to do other things like push characters around or reposition them relative to one another. It also lets you do things like taking over camera control and applying damage. A lot of people will probably use the Grapple component to create things like execution moves, throws in fighting games, or for instance situations where one character is carrying another character or for example reviving an ally. So these are all things you can create with the Grapple component. Now in this tutorial I would like to show you how to add the Grapple component to your own project and how to implement it within your own character blueprints to make your characters compatible. And then I would also like to show you how to create your first interaction in the form of a Grapple sequence. So let's get started right now. The project we will be using for this tutorial is this one. Essentially, it's just a modified version of the third-person template that comes with the Unreal Engine, but in here I've added some custom skeletal meshes and animations that are all downloaded from Mixamo. So Mixamo is a platform by Adobe that gives developers access to some free skeletal meshes and animations that can be really handy for prototyping or for tutorials like this one. For those who are interested, I will provide a link to this project in the description below the video. Let's start out by adding the Grapple component and its files to our project. For those who are interested, the Grapple component is available on the Unreal Engine Marketplace and it can be added to your projects using the Epic Games launcher. Once you've purchased the Grapple component, it should be available here in the launcher. To access it, open the launcher, make sure you are in the Unreal Engine section and navigate to the Library tab. On the bottom of this tab, there is a section called Vault, where everything is stored you have access to thanks to the Marketplace. In here, you should be able to find the Grapple component using the search bar on the top right corner. If you've just purchased the Grapple component and it doesn't show up immediately, you can try restarting the Epic Games launcher. When you find the Grapple component, press the Add to Project button. In here, you can select the project you want to add the Grapple component to and then click Add to Project again. If it asks you whether you want to overwrite files, I would recommend making a backup of your project before adding, and then clicking Yes. So here we are again in our tutorial project, and as you can see, the Grapple component files are installed right next to the files of our tutorial project. Now, if you open the editor and you don't see this level immediately, you can just go to the GC tutorial folder and then select the GC tutorial map, GC standing for Grapple component, of course. And now again, this level, this entire project does not contain a lot of functionality by itself. It just has this rudimentary character that can move around. It doesn't really do anything because it's made just for me to show you how the Grapple component works. To make the Grapple component work within your project, you really only need to add it to the characters you wish to use it on. In the case of this example project, there really only is one character, namely this GC tutorial character. If we open it in the Blueprint editor and navigate to the Components tab right here, you will see that only some basic components are present that are also present in the third-person template. What we should do now is click the Add Component button and look for our Grapple component. It should show up in the list here, and if we click it, it is added to the character. This means that our character is now able to enter into interactions with other characters. When you are done making these changes, don't forget to click Compile and Save. Now, one of the functionalities of the Grapple component is to play animations on the character's skeletal mesh. Now, to make this work, we will have to do some modifications on the animation blueprint that is used by the skeletal mesh. To do this, we navigate to our Grapple Component folder, and click BP Grapple Component, AnimBP, and look for the Grapple Component _ AnimBP blueprint asset. What we need to do now is right-click this object and then create a child blueprint class of it. We will move this class to somewhere we can easily access, like our GC tutorial folder. Now, if we open up this asset, the only thing we really need to do is press the class settings button over here and then navigate to the details tab. Over here, there should be a section called class options, and if you see the little arrow here, you can use this to expand this menu to show the advanced options. This variable right here, the target skeleton, should be changed to the skeleton that is used by your character. In our case, this is the GC tutorial _ skeleton. Let's compile this blueprint, save it, and then we can close it. Now, with this new blueprint class created right here, Grapple Component _ AnimBP child, we should find out what the animation blueprint used by our character is. We can do this by once again opening our character, clicking its skeletal mesh, and then looking in the details panel. There should be a section called animation, and under here, for most characters, the animation mode selected will always be use animation blueprint. You can then look at the anim class, and that class is the animation blueprint that's used by your character. You can locate this in the editor by pressing the magnifying glass here. If we now minimize this window, you will see that the animation blueprint is selected in the content browser. Let's open up the animation blueprint, and if you don't have it open yet, navigate to the anim graph. Now, with this new blueprint class created right here, Grapple Component _ AnimBP child, we should find out what the animation blueprint used by our character is. We can do this by once again opening our character, clicking its skeletal mesh, and then looking in the details panel. There should be a section called animation, and under here, for most characters, the animation mode selected will always be use animation blueprint. You can then look at the anim class, and that class is the animation blueprint that's used by your character. You can locate this in the editor by pressing the magnifying glass here. If we now minimize this window, you will see that the animation blueprint is selected in the content browser. Let's open up the animation blueprint, and if you don't have it open yet, navigate to the anim graph. In the animation graph of our character, we should right-click any place in the graph and look for a node called linked anim graph. Add this node, click it, and then navigate to the details panel. In here, you should see an option called instance class. This instance class should be the blueprint we just created. In our case, only one option shows up, which is the right one, Grapple Component _ AnimBP _ child. Let's click this class, and we should see that an input post pin has been added to the node. Now we simply need to connect this to our default logic. So by that I mean the nodes that were already there in the character blueprint. In this case, it's just a default locomotion node and a node used for montage slots. So we connect that which already existed, to the linked anim graph, and we connect the output pose of our linked anim graph to the final output pose of this blueprint. Now we can compile, save, and close this. With these changes made to our character, the Grapple component is now able to communicate with the skeletal mesh of the character and send animation updates over to it. What we want to do in our game is create a sequence where this character walks up to the other one, and then when we press one of the mouse buttons, an animation plays where these characters interact. To make this happen, we will first need to create the actual interactions. Interactions here, in the context of the Grapple component, are defined in the form of Grapple objects. To create a new Grapple object, we simply right-click an empty space in the content browser and then create a new blueprint class. You can type Grapple object here in the search bar, and the one we are looking for is the Grapple object underscore struct based. This is a Grapple object with some additional functionality that allows us to define all the effects of the Grapple sequence using a set of variable structures. So let's click this Grapple object struct based and press select. We have now created a new blueprint. Let's start out by making a small tackle animation. The animation assets for this are included right here in the animation folder. So let's focus on the Grapple object for now. Let's call this object G underscore tackle. Now that we have created our new Grapple object, which will define our interaction, we will need to activate it through our character. So to do this, we need to open the character's blueprint and navigate to the event graph. In here, we can add an input event that will trigger our Grapple sequence. In our case, I think I will go with the right mouse button. Now, when this right mouse button is pressed, we can access our Grapple component. A quick way to do this is by just dragging this reference from the Components tab to your blueprint graph, and then dragging from this Grapple component node and looking for the Grapple attempt input node. Now this is quite a simple node that allows your character to activate a Grapple sequence of your choosing in case certain conditions are met. So it's the typical way to start an interaction from gameplay. We will get into the details of this later on, but for now we will just select our Grapple object class, which is the Grapple sequence we are creating, i.e. our tackle, and then compile and save the blueprint. One more thing we should do in our character blueprint is making sure that the Grapple component actually knows which other characters it can grapple or which other characters it can interact with. To do this, so a sort of default way is built into the Grapple component. If you add another component to your character, this time a box collision component, and then you place it as you would place a standard hitbox. So let's make it tall enough, wide enough, so that you could say everything that is in this box will be considered as a participant for our Grapple sequence. So essentially this will be our range, this box right here. Now, to make the Grapple component find it automatically, we need to make sure the box is selected. And then in the details panel, look for the component tags. They are over here. And add a tag called default Grapple hitbox. This is just something that is built into the Grapple component so that it can work out of the box without you having to do any complex setups in your Grapple object. But please do keep in mind that there are also other ways that the Grapple component can search for targets, like a line trace, for example. But for now, we will just stick with this default Grapple hitbox right here. So let's compile and save and test our project. Now, if you play this project and walk up to another character and press the right mouse button, you will notice that nothing really happens except for the fact that you cannot move anymore. That's because every Grapple object is just an empty container by default. It does not do anything unless you tell it to do anything, except for the fact that it locks characters into place until it's instructed to do something else. Now, to add some functionality to our Grapple object, let's open it in the Blueprint editor. And let's navigate over to the My Blueprint tab, and then under the Functions section, press this override button right here, and look for a function called Generate Global Grapple Data. This global grapple data function will define all the effects and consequences of our grapple sequence. For instance, if a character plays an animation during the interaction, it is defined in here. If it's repositioned relative to another character, it's also defined in here. The same goes for movement capabilities that are affected, for example, if a character is locked in place, which you will probably want for most of your grapple sequences. Or if you want to take control of the camera, for example, that all goes here in the Generate Global Grapple Data function. Now, the main thing you should pay attention to here in this function is this output pin, the Global Grapple Data. We can remove the call to the parent function here. So if this, as you can see, this is a variable structure, so essentially a variable that consists of more variables that go inside it. You can check this out for yourself by dragging off the pin and typing in make, and then if context sensitive is enabled, it should automatically make a variable structure of the right type. So as you can see, there's multiple settings you can set here, and most of these expand in more and more settings, with this pin right here expanding into settings that can be set for each participant, so for each character in the interaction. But for now, we will not deal with all this yet, and instead we will just again drag off this output pin and type in, with context sensitive enabled, generate. Now, normally you should see a macro right here, Generate Global Grapple Data Simplified. And what this macro does is it allows you to set this global grapple data by only defining the bare necessities, so to speak, so the most commonly used pins. If we have a look inside, you can see that the graph is a bit more complicated and the actual variable structures are used. But for now, for this grapple sequence, we will just make use of this pretty standard node. So the most fun thing to define here are probably the animations for your participants. So let's first have a look at the different animations that we will be using for this grapple sequence. We can look at them by navigating to the folder GC tutorial, animation, tackle. As you can see, there is one animation that is basically a character tackling no one yet, because it's just one character. And then another animation where we are being tackled. Now, one of the main functionalities of the Grapple component is to put animations like these together in a way that looks smooth and that makes intuitive sense to players. So I will now show you how to go about this. In our Generate Global Grapple Data node, we can first select the animation for participant 0. Now, this participant 0 is actually the first character that is partaking in our interactions. So most likely it will be the one that is attacking or that has initiated the interaction. So we can look for our tackle animation right here, and it's already been labeled _00 because it's meant for participant 0. And we can do the same here for participant 1. Please also keep in mind that these animations, while I did download them from Mixamo, they have been adapted a little bit, because when you download them from Mixamo, characters might not always start the animation in the same place where they will be at the end. So gameplay wise, I have made some corrections to the asset, but you can rest assured that the ones included in the project are the corrected ones. So you can use these in your Grapple sequences. Now we have just added these animations. Let's see how that looks in game. Don't forget to compile and save, and then you can press play. So when we play our game, walk up to another character and press that right mouse button. You will see that the animations are in fact playing, but that the character's positioning is a bit strange. It's not quite right. And also that the grapple sequence is ending a bit too early. Characters do not have enough time to get back in place before their animation ends. So let's see how we can fix that. So back inside our grapple object, we can set the duration to, for example, 3 seconds instead of 2. The 2 default value is just there as a placeholder. In most cases you will want to change this to the actual length of your animation, or at least of your grapple sequence. Now let's hit compile and save and see how it looks in game. So you can see that timing wise this does look a little better, but it still looks quite odd because the characters are not in the correct relative position relative to one another, so they're kind of clipping through one another. We can fix this by increasing the relative location. So this is basically when you have your participant 1, so the target, it will always be repositioned in such a way that it's being placed in the world relative to participant 0, which is the character that initiated the grapple sequence. So these animations were made for one another, but they were made in such a way that characters should be placed at 160 units apart in the game world. So under relative location, we will try putting 160. Now, if we see how this looks in game, you can see that the characters look a bit more as if they are actually interacting because their transformations appear correct. Another thing I noticed is that the build-up on this animation is a bit too long, and it doesn't really look natural if you initiate this from gameplay. Like, you might notice that right after I click, the character is still moving a little bit and preparing for the tackle. Most of the time when we're playing a game, you want the tackle to happen immediately with less of a delay. So we can try fixing that once again in our grapple object by increasing the start time to, let's say, 0.35. I may or may not have tested this out already. So as you can see, that looks a bit more, it feels a little bit more impactful because the animation is happening right as we are pressing the button. Another thing that I find quite annoying to watch is that when we perform this grapple sequence, the second character's animation is not quite long enough, and when it gets up after the animation, it looks a bit odd that it just blends back into its idle pose. So maybe we can fix that by adding in a getting up animation. So luckily I have put in a few get up animations here that were once again downloaded from Mixamo. So let's see if we can get this into our Grapple object. In fact, I know we can. We can do it by navigating to our event graph and then right-clicking any blank place in the graph and adding an event on, again, event on initiate. So this event will be called by the Grapple component whenever we start with the Grapple sequence. Now, to this initiate event, we will connect a queued event. Queued events are things that are bound to happen in your Grapple sequence at a specific time. You can use this, for example, we don't have damage integrated in our project, but for example, you could, when these characters hit the ground, apply some damage to the second character right here. But we don't have damage built into this game, but we can queue in a different animation for the second character. So to queue in this getting up animation, we should drag off this execution pin on the on initiate event and look for a node called add queued event. So in this node, there is a parameter called function name. This should be the name we want to give to our event. In our case, let's go for get up with a space in there. And we want this event to execute after, let's say, 2 seconds. We can tweak this afterwards if we want. Now, we should now create a custom event on our Grapple object, and it should have the same name we specified in here. So just get up. So let's put get up as the name of our custom event. And this node will now be executed 2 seconds after the Grapple sequence has been initiated. The other parameters we will just leave as is. We do not need to worry about them for now. So we have this event right here, which will be executed after 2 seconds. And we want it to do something on our participant with index 1. So that's the character that is being tackled. So to get a reference to this participant, we right-click any place on the graph and type in get participants by index. Let's go with the validated version, because if for any reason there is no valid participant 1, the functionality will just not run, but it will not give any errors. So let's make sure to also select our right index in here, which is again 1. And this will give us a reference to a Grapple component, because when you have the Grapple sequence, all of the participants, they refer to characters, but in reality, these are Grapple component object references. This is done because the Grapple component has all functionality you need within the Grapple sequence, and you can also use it to get references to any other objects you might need. So the Grapple component really is the central hub that represents a character within the Grapple sequence. So let's drag here from this participant Grapple component pin, and let's make it update the animation of the character to play the get up animation. So let's find update animation input. And this is the node we can use to update the animation on the character. So animation updates on the Grapple component are always processed using this node, update animation input, and they are sent over the animation updates using a variable structure here of type animation data. So you can get a view of this data structure in its entirety. You can use a make struct gc animation data node if you want full access to all the update parameters. But what we will do instead is once again use a macro called generate animation data. And Right here you can select from a couple of presets. In our case, I know for a fact that we will be using an animation montage. So I will be using the macro called generate animation data montage. On this macro, I can simply select the get up animation. If I recall correctly, the character was facing up before they got up. I will put 0 as the blend time, because animations like this can look a bit weird if the character was not lying in the exact correct position before the animation starts. So I'm just going to put 0 as the blend time. Start time can be 0 as well. Play rate can be left at 1. It does not need to loop. Force restart animation we want enabled, and then root motion we do not need to modify. So here in conclusion, after 2 seconds we will play our get up animation on the first character. Let's compile and save, and then we can test this out in game. So if we test this out in game and walk up to the other character, press right mouse button, you will see that they in fact get up automatically when the grapple sequence is about to end. After 2 seconds. Actually, the 2 seconds might be a bit too long. Let's see if I can make this 1.75. Yeah, that looks a bit better to me. And you can also tweak other things, of course. Let's say this is a pretty basic setup because we are using the macro, but still, if you would want to put the characters a bit further apart, let's, for this example, say 500, which is of course absurd. You can see that the characters are actually 500 units apart, but 160 will do just fine for these animations. You can modify the animation start time. Actually, 0.4 might be better over here. And the blend time could also be a bit longer. I think for animations like these, that might look a bit better. Yeah, it has a little bit less of a punch to it, but I think it looks better because there is a bit time the animation needs to build up. So yeah, you can mess around with this and then, depending on your animations, create these variables however you want. And if you're ready for a more advanced step into creating these grapple sequences, you can, of course, define all of this manually. We will get to that in a minute, in fact. So I am quite happy with the result of this grapple sequence, the tackle. So now we might be ready for something more advanced. So now let's try and create a grapple sequence that is a bit more advanced. And what I would like to go for is one where if we grab this character while standing behind it, I want it to play an execution animation that also intuitively for players, as you see this animation is made to be played while facing each other. I want it to play an animation that is made for a situation where the other character is facing away from us, some sort of a stealth assassination. Now, luckily, I have in the folder GC tutorial animation stealth assassination downloaded 2 of these assets from Mixamo. So one where we are jumping on another character's back, and one where the character's back is being jumped on. So we will now put these together in one grapple sequence. Now, to create the grapple sequence for our stealth assassination, let's navigate to our GC tutorial folder and right-click an empty space in the content browser. We will then create a new blueprint class and once again select grapple object, and don't forget to pick grapple object underscore struct based. Let's open this and let's call it G underscore assassination. Let's open this blueprint and once again override our function generate global grapple data. There we go. So this time around, we will be going for a more advanced setup. And what I mean by that is that we will no longer be using this generate global grapple data macro, the simplified version, but instead we will use a node that's called make global grapple data. Really quickly, I would like to show you what a setup like this might look like in its final form. So you have this global grapple data, which is made by this node right here. But as you can see, that expands into more options, which in turn can expand into more options. So the entirety of your grapple sequence might then look something like this. If this looks a bit overwhelming for now, don't worry, I will guide you through the process. And also, if you are ever stuck, there is an entire section here in the documentation that is dedicated to the effects of the grapple sequence. So that section will also guide you through everything there is to know on global grapple data and local grapple data. And even then, if users are ever stuck, you can always contact me using email or on the Discord server. So let's close this example from the content examples and go back to our assassination grapple object. So back in our own grapple object, and once again inside the graph of function generate global grapple data, we can just delete this call to the parent function because it is not really connected to anything. The only thing we do have in this graph is the make global grapple data node. So this node essentially defines the properties of your grapple sequence as a whole. It does not tell you anything about what will happen to an individual character, but it does tell you where will this event take place, what will be its name, what will be its duration, and things like that. One thing you will always want to change here is indeed this duration member variable, because when it's set to a negative value, which is the case by default, it will never end the grapple sequence. It will just keep going indefinitely. So let's change this to 6 seconds, which is my estimation of the animation length, and go to the next step. The next step being our local grapple data. Now the local grapple data are the settings that apply to a single character in your interaction, so in your grapple sequence. So individual animations, individual transformations of characters, the fact whether they can move or not, that's stored in here. And of course this is an array, so to gain access to these settings, we will need a make array node, because one element will exist for each character that is a participant in this grapple sequence. So as was the case for our last interaction, we only need 2 really. 0 is for the character that initiated the grapple sequence, while 1 is for the character that we are targeting. So dragging off this element 0 pin, let's make local grapple data. Once again, I recommend you do have context sensitive enabled around here, because in that case, if you type make, the right node will appear immediately. So let's click this. And this node will once again define the effects of the grapple sequence that apply to a single participant. So this will be different for each of the characters in the interaction. We can copy this node and paste it below, and connect the node on the bottom here to array element pin 1. So what do we need from this grapple sequence? As I mentioned, we need this character to walk up to the other character and then play the takedown animation. So the most obvious way to translate this into the grapple data is to start with the animations that characters should play. So let's look at our local grapple data for the first character. So the character 0 here, participant 0, which is the one that is attacking. we can drag off this pin right here, animation on apply, to define an animation that the character should play when it enters the grapple sequence. In our case, we want to use an anim sequence, so we can type in generate, and it will autocomplete for us, and we have all these options to generate animation data. In our case, we need an anim sequence. The animation sequence that we want will be the assassination _00, which is once again the one where one character is jumping on the back of another character. Now, blend time looks alright, start time as well. Yeah, this all looks good. Now we can just copy this node, this macro, paste it below, and hook it up once again to the animation on apply. But for this character, of course, we need to play the other animation, assassination 01. Now, if we compile this and save, let's see how it looks in game. Of course, this does not do anything yet in game, because our character is only set up to play the other grapple sequence when we press the right mouse button. So to change this, let's go back to our character, which is here in the GC tutorial folder, and go to its event graph. So if you remember, we set this up in a way that when we press the right mouse button, the character calls this node, grapple attempt input, on the grapple component, and the object class that we are initiating is G_tackle. Now, in this case, we want to change it to G_assassination. The character will now initiate the right grapple sequence when we press the right mouse button. So in game, this looks as follows. So we can see the animations are being played correctly, but characters are not being repositioned in the way they should. So this can be fixed. When we want to change settings that are related to repositioning, we should first think about what do we want to reposition the other characters around. So essentially, when one character is attacking another one, what do you want to be the center, or perhaps more correctly, the origin of this grapple sequence? What should it be based around? Because we have one character that is jumping on the back of another character, it seems to me like the basis for our grapple sequence should be the character that is being attacked, because that's the one we are moving towards. Now, we can translate that into grapple data by dragging off this pin right here, the scene root, and then once again typing in make, and it will select the right node for us. In this case, it's a variable structure of type attachment definition. So this essentially just defines a point in the game world we want to attach something to. So most of the time for grapple sequences, you want to leave this at actor root component, but you can change this index to modify which character is the basis for the grapple sequence. So in this case, we want to change this from 0 to 1. Now, when we have defined our scene root, the grapple component will automatically create an actor that has a scene component, which is used as the main center point, as the parent for the grapple sequence, so to speak. So all other characters will be repositioned relative to this scene root. Now, to determine their position relative to character 1, in our case, we can go to the local grapple data, which again is different for each participant, and drag off this repositioning pin. So this pin gives us access to a few things, but once again, to keep it simple, I would suggest just typing in generate and then going for the generate local reposition data simplified node. This will provide us with a simple way to define where a character should be in the grapple sequence. So if you recall earlier, we have specified that the scene root for the grapple sequence should be the actor root component of participant 1. And remember, participant 1 is the character that is being attacked. I would like to take a moment to visually show you how these characters will actually be placed inside the game world, because I think it provides a good illustration on how the grapple component handles repositioning and how characters are placed relative to one another. So we have here the two animations that we are going to use, Assassination 0 and Assassination 1. We can drag them into the game world, and they are standing at the same location right now. So if we play these animations now, you can see that timing-wise they do look correct, but their transformation in the game world is not correct. This is because the character that is attacking should be standing behind the character that is being attacked in order for this animation to make sense. So to realize this, let's quickly parent our character 0 to character 1, because that will also be the case in our grapple sequence. If you recall correctly, character 1 was the root scene component. So as you can see now, when we move character 1, character 0 moves with it. What we want to achieve is a situation where character 0 is being repositioned in such a way that it ends up 100 units behind character 1. If we play the animations then, you will see that they line up quite well. We don't have to play around with rotation, because in this gameplay situation we want it to be so that the character is standing exactly behind the other one. It's kind of the ideal situation for this grapple sequence. So let's see how we can translate this into our reposition data. So as we have just established, the participant 0 should be placed 100 units behind participant 1. This can be done right here in the reposition data by replacing this 100 by -100. This will have the character stand behind the other character. Now in here it says rotation, relative rotation, 180 degrees. That's because in most cases when you're making a grapple sequence, you want characters to be facing each other. And always, when you have two things facing each other, they are at a relative angle of 180 degrees. In our case, we want the characters to be looking the same way, so we change this to 0 degrees. Now we can compile this grapple sequence and save, and see how it looks in-game. So in-game you will see that the character is indeed placed correctly relative to the other character, but it looks quite odd that even if we are attacking from an angle, that we are kind of moved and then turned a little bit to fit the original transformation of the participant 1. So we should fix this by having the characters face each other first and then repositioning them. The way we go about this in our grapple object is by accessing the global reposition data. So to do this, we drag from this pin and add a make global reposition data node. And in here we can instruct the grapple object to use a look target. So the look target will take the scene root, which again is placed here at our character 1 root component, and it will rotate it towards another scene component. In this case, if we drag off look target and once again make an attachment definition, we want to rotate it to the actor root component of participant 0. So our scene root is being rotated towards the location of the attacker. Now, in this case, we don't just want the character 1 to look at character 0, we want it to look 180 degrees away from character 0. So to achieve this, we drag off this relative transform pin here, and add a make transform node. And to add this rotation offset, we can just add 180 to the z-axis of the rotation here. So let's test this out in game. So when we walk up to this character, you will see that the character 0 is being placed correctly, but the character 1 is not really being adjusted. It's just been, it looks like it's moving, but it's just the animation being updated. So this is actually because in our Grapple object, the character, the participant 1, does not have any reposition data specified like the character 0 does. So let's copy this reposition data node and add it to our second character as well. Now, in this case, we don't want it to be 100 units behind the scene root, but we want it to be 0 units behind it. We want it to be at the exact same location as our scene root, because once again, we are basing our entire grapple sequence on this location of participant 1. So let's see how this looks. So if we approach the character from an angle now, you will see that the characters are turning first and then repositioning themselves. However, I do still think that it looks a bit strange that the character seems to be moving backwards a little bit. That, once again, is because of the animation asset, but we can correct this by moving everything forward a little bit. So, for example, if we had the first character not be 100 units behind the scene root, but only 50 units, and we would put the first character 50 units in front of the scene root. This should now look a bit more natural. Well, at least to me it does, but there is still the problem that we have this large buildup. When we click the button, you see she's walking for about 1 or 2 seconds before actually engaging the target. So to fix this long build-up time, we can just cut a bit of time off the animation. For example, we could start the animation at 1.5 seconds. And then, of course, we should do the same for participant 1. Let's see how this looks. Oh, that's a bit too abrupt. Let's go with 1 second. So that looks already a lot more natural. We can just walk up to a character and then right click and we jump on their back. Perfect. So you might look at the Grapple object now and think this is a bit cluttered, but we can reorganize these nodes a little bit to keep it simple. So we have our function output right here. And once again, our function output is the global Grapple data, which defines the effects of the Grapple sequence as a whole, so not linked to a certain participant. This global Grapple data tells us a lot of things. For example, the scene root here, which is in our case placed at the location of the first character. There also is the global reposition data. And then there is the local Grapple data, which defines the effects of the Grapple sequence for each individual character. So this is the local Grapple data for participant 0. And this is the local Grapple data for participant 1. So that looks a bit more structured, and maybe it's easier to find our way in the blueprint now. So while I am quite happy with the result of this Grapple sequence, I do still think that it looks a bit awkward when this target falls on the ground and then immediately gets up again. So just like we did in our previous grapple sequence, the tackle, we can add a get up animation here as well. But just to spice things up, we can add it at a bit of a different time. So during our previous grapple sequence, we used a queued event to make the character stand up during the grapple sequence. We can also hook this standing up animation up to the end of our grapple sequence, so that the character only gets up at the time the grapple sequence is over. So when the rest of the animations are done, then the character will get up. So let's try that. So to add an event at the end of our grapple sequence, let's navigate to our assassination grapple object. Then let's click out of the generate global grapple data function and into our event graph, which you can find over here. Now let's add an event called event on terminate. So this event will fire when the grapple sequence ends. In our case, because we still need references to the different characters that are in the grapple sequence, we will use event on terminate before. Now, this will allow us to play an animation when the grapple sequence ends. So let's go to our event on terminate before, drag from the execution pin, and then once again get a reference to a participant by index. In this case, we once again are looking for participant 1. And when we have a valid reference to this grapple component, let's once again use the update animation input node. Just like before, we connect all these pins and we generate the animation data. However, in this case, we are using a different montage because the character is facing down. So we type in get up and we select the facing down animation. So right now the character will, when the grapple sequence is over, character 1 will play this animation instead of just blending back into its idle animation. The only thing we should do is, because the grapple component, when the grapple sequence is over, it automatically cancels all animations that were played and caused by a grapple sequence. So we don't want to do that this time. We don't want to manually stop all animation when the grapple sequence is over. So that's why we should, for our participant 1, the target, overwrite this pin right here on revert. By default, this just instructs the grapple component to stop all animation. We want to overwrite this here by using a macro called generate animation data unchanged. And this will stop the grapple sequence from just blocking all future animation when it ends. So let's compile and save and see how it looks in game. So when we walk over to the character now and we watch our animation play out, we will see that it will start to get up after the grapple sequence has ended. And this is, keep in mind, this is during the time we can already move again. So grapple sequence is over and then character gets up. So that looks as intended. Now that we have these two grapple sequences, it would be nice if the character knew by itself which one to activate. So, for example, right now, if we approach this character from the front and we press the right mouse button, it will attack the target as if we initiated it while standing behind the character. So it would be much better, of course, if it did this when we are standing behind the character, but it did the tackle when we were standing in front of the character. So this is very much doable, and I will show you how. So we want to create a setup where there's two options, where the character, if conditions are fulfilled for one grapple sequence, it initiates that one, and if not, it initiates the other one. Because our stealth, our assassination grapple sequence is the most exceptional one. In most games, it will also be the most powerful one. We will test that one first. So when we approach another character, we will first check, are we standing behind the character? If yes, initiate the special grapple sequence, the assassination. If not, initiate the regular grapple sequence, i.e. the tackle. This can be realized by opening our character blueprint and just performing both grapple attempts, one after the other. So we will be trying the assassination first, and then we will be trying the tackle. And in case the assassination is successful, this attempt will not be successful because we are already in a grapple sequence. And one of the conditions to enter a grapple sequence by default is that you are not in one already. So if the first one is successful, the second one will never initiate. If it's not successful, the second one might initiate, if there's a target found, of course. But if we test this right now, obviously, it will always initiate the assassination. That is because we have no conditions set up. So as long as there's a target found, it will initiate the grapple sequence. Of course, if our hitbox is not overlapping with anything, you can hear me clicking, but there's no grapple sequence initiating. That's because the grapple object has not found any target. But from the moment we enter in range, it will initiate when we click the button. So to set up this condition that we should be behind our target in order for the grapple sequence to initiate, we can navigate to our G_assassination blueprint class and navigate to the my blueprint panel, the functions section, and then override a function called test selection conditions on candidate. Now this function will just check if we find a character that is overlapping with our hitbox, is this character actually suitable to enter this grapple sequence? Now, by default, there is some functionality there that just tests, is this character in the right state to enter the grapple sequence? So, for example, is it not already being grappled by another character? Because in that case, we don't want these two grapple sequences to interfere. So that's why I would recommend leaving the call to the parent function here. But we can add an additional requirement that that we are standing behind our target. So to add this additional requirement, we can right-click the graph and use a macro called isStandingBehindTarget. So we want to initiate this grapple sequence if we are standing behind the target and, so let's add an and node, and if the regular requirements are also fulfilled. So if the other character is in the right state to enter a grapple component. I should also point out that right here, the tested grapple component should be our master grapple component. So what this means in the context of a grapple object, when you use this get master grapple component node, it will always refer back to the one that initiated this grapple sequence. So in our case, this character, and more specifically, this component. So this is essentially the attacker. The target grapple component should be the one that you want to be standing behind. So in our case, the target. Now the target in the context of this function is the candidate grapple component. Because if you look at our game world, this will always be our attacker, and these two will be candidates to join the grapple sequence. So whenever this function is called, it is just testing if these yellow characters are fit to join the grapple sequence of the red character. So to briefly recapitulate, the grapple sequence will start if the normal conditions are fulfilled and if the master grapple component is standing behind the candidate grapple component. And if this is all in order, the grapple sequence will start. If not, it will fail and the character will proceed to the next attempt. Let's see if it works. So let's first attack this character that is facing us. And as you see, that looks so outright. And now let's attack this character that is not facing us. And as you can see, that plays the other animation. So we have now two grapple sequences that each fire depending on the context. Just to really quickly mention this as well, if you go into the assassination grapple object, into the selection conditions, you can also make this angle a bit more strict. For example, if we make it 20 degrees, you will need to stand right behind this character, because if not, it will just do the tackle instead. While if you are standing right behind it, it will do the assassination. But I think 60 is quite ideal for situations like these. It just, when you're standing more or less behind the character, it will kind of nudge them in the right direction. Something I did notice as well is that we did not set any movement settings for our grapple sequence. So a consequence is that when we run up to this character that is not facing us and we run and jump and then initiate the grapple sequence, you'll see that the characters are sliding a little bit and are not in the right place anymore. Now, we can fix this by navigating to our G_assassination object, then selecting the generate global grapple data function, and then for each participant, if you look at the local grapple data, there is a pin here called movement. If you drag from this pin, you have two options really. You can either opt to make the movement data in its entirety, which gives you all of these options. Most of them relate to the character movement component. Or you can go for a more streamlined option, which is to generate movement data from presets. Again, another macro. You can select, if you choose this option, from different movement data presets, which you can make for yourself as well, by the way. In most cases, so for most grapple sequence, you will want to select this one, MD_rooted. It disables movement on characters, stop them from walking, rotating, jumping. And you can apply this one to both characters actually. So we can copy it and paste it over here. And now both characters will be rooted during the grapple sequence. So if we run up to this character, jump and grab it while in the air, it still does look correctly transformation-wise. Actually, I'm quite bothered by the fact that we can just run up to this character, jump in the air, and then initiate our grapple sequence. It does not look all too natural animation-wise, but we can change this so that our character can only initiate the assassination when it's not in the air. So to do this, we just open our assassination grapple object, and then under the My Blueprint tab, look at the functions, press the override button, and override the apply selection criteria function. Essentially, this function just says when we find a certain group of candidates, what do we do with them? So the normal answer would be, if these candidates fit the right conditions, just initiate the grapple sequence with them. But we can add an additional requirement here, that is our master grapple component in the air? And if it is in the air, we do not initiate. Now, to add this condition, just do the following. We get a reference to our master grapple component, which once again is the character, essentially, that's initiating our grapple sequence. We get our linked character movement component. And on this character movement component, we check the variable is falling, I believe. Yes, is falling. So this will actually return an answer to the question, is our character in the air or not? And we will only continue with the grapple sequence if everything is in order according to our parent function and the character is not falling, because we do not want the character to be able to do the assassination if it's falling. So this, if we compile and save, should prevent us from initiating the grapple sequence while we are in the air. Of course, we need to do the same thing for our tackle as well, because otherwise it will just start that grapple sequence instead, which is not what we want. So here we should apply override function, apply selection criteria as well. Make sure the parent function is connected. And we can just copy and paste what we've done over here in our other grapple sequence. Now, when you're making an actual game and you want this to be an additional condition for all your grapple sequences, it is better to just create a parent class, so a parent grapple object, and make these two grapple sequences, or every grapple sequence in your game, a child of that class. So you can really use the object-oriented programming to your advantage there. But for now, because we're only working with two grapple sequences, let's just go with this setup where we define this condition in both of our graphs. So if we compile and save both of these, we should no longer be able to initiate this grapple sequence while we are in the air. And that seems to be working. So there you have it. With relatively little effort, we have now managed to create two interactions that we can initiate based on the circumstances of our game. These are only a few of the features that the Grapple component has to offer, and it's likely that I will also make some tutorials on the other ones. In the meantime, you're very welcome to ask any questions you might have. You can send me an email at support@johnvandam.com, or you can join our Discord server where we also like to talk about the Grapple component. Any questions, suggestions, or feedback you might have are very welcome, because I'm always looking to improve the project. But for now, I will thank you for your attention during this video, and I will see you in the next tutorial. Bye.